We're going to continue to solve equations with square roots. The issue still ultimately is we'd like to isolate the square root. And in this case, there just happen to be two things, x and 2, that we need to move to the opposite side in order to isolate the square root of x plus 4. So when we do the appropriate thing, we get the square root of x plus 4 equals x minus 2. Now, we need to square both sides. If you square a square root, you always get the radicand, so this would be x plus 4. Remember that x minus 2 squared means x minus 2 times x minus 2. You could distribute, you could use FOIL to multiply the right-hand side out, but however you do it, you should get x squared minus 4x plus 4. This is a quadratic, so we'll need to get this equal to 0 first. This one actually works out really nice because 0 equals x squared minus 5x. I'm looking to factor, and I can see that there's a GCF of x, so I'm going to factor that out first, which is great because that means that either x equals 0 or x minus 5 equals 0, so x could equal 5. So we've got our two possible solutions. But as always with square root equations, we need to check them. We'll start with 0. The square root of 0 plus 4 minus 0 plus 2 should equal 0. So the positive square root of 4 plus 2 should equal 0. But that is not true. 4 does not equal 0, which means that x equals 0 is not a solution. It is extraneous. We'll need to check our other one. There could be two extraneous, I suppose. The square root of 5 plus 4 minus 5 plus 2 should equal 0. This gives us the square root of 9 minus 3 equals 0. The positive square root of 9 is 3, and 3 minus 3 is 0. So there's a single solution in this case. It's x equals 5. Again, this is an example of why you always have to check. It isn't always obvious how to tell when you will have an extraneous solution. Why don't you try another one? Let's try 3. Let's look at another one. 3 times the square root of 3x minus 5 minus 8 equals 4. Now this problem appears to be it's similar to everything else. We just need to isolate the square root. And the first thing that needs to happen is we need to add 8 to both sides. That'll leave us with 3 times the square root of 3x minus 5 equals 12. Now I'm going to show you two options. I'm going to show you the option that I personally prefer, and I will also show you the option that the book uses. There's no difference, and each will give you the same place, but the method is different. Since this is 3 times the square root, I'm going to divide both sides by 3 to isolate the square root. So this will divide out. That will give me the square root of 3x minus 5 equals 4. So one option is to divide that constant on both sides. Here's option 2, and this is the way that your textbook happens to describe it. So I just want you to not be confused by the different things. This is the second way you could do it. They elect to square both sides right now. When you do that, on the right, we'll do that first, 12 squared is 144. And we know that if you square a square root, you get the radicand. In this case, it'd be 3x minus 5. But there's also this part, the 3 squared. 3 squared is 9. Now at this point, you could divide both sides by 9, and conveniently, this is going to give you 3x minus 5 equals 6 14. Now something to notice. If we go back to method 1 and decide to square both sides, we also get 3x minus 5 equals 16. So you really need to decide which method do you prefer. Personally, I almost always do option 1. But you could choose to do option 2, and it's really just personal preference. From here, since they're the same problem, I'm just going to add 5 to both sides. So 3x equals 21. Dividing by 3, x should equal 7. We still need to check our answers, so we'll go back to the original problem. 3 times the square root of 3 times 7 minus 5 minus 8 should equal 4. Well, 3 times 7 is 21, and 21 minus 5 is 16. The square root of 16 is 4. 3 times 4 is 12. And 12 minus 8 is indeed 4, so this checks out. This is our solution. We did a good job. So there's 2 different kinds of problems, but nothing's really changed. We still need to isolate the square root in some way and square both sides.